First thing I want to talk about is different equations, what's similar, what's different. How many different processes have we dealt with in chapter 8, like 4-step process? 3 or 2, somewhere in there, because the mean is split as 2 different ones. So we're going to write with all 3 of them and like answer each section for the stuff that changes. So we've got I don't know how much room I'll have. So where all of this is going to be means, this is proportions. What in the problem do we get to decide which of the 2 means it is? Like, what is given in the problem that tells us which one it is? Given or not given?
Standard Newton.
So either sigma is given or sigma is not given. And then that splits our whole process, which obviously there's not going to be anything right there in proportions. So let's start with our confidence interval equation. So what is our confidence interval equation for, and we'll start down here with proportions. What does it start with? What does our confidence interval for proportions equation start with? What does the confidence interval equation for proportions start with? D hat. D hat what? Plus or minus Z times what? And all that's over . So what does our confidence interval equation start with for means?
X bar.
Are y'all just behind and getting caught up writing to where I am? I'm hoping that's why y'all aren't responding. I'll give you a second to get caught up. All right, so if sigma is given, it's x bar plus or minus what?
Z.
And then times which one?
Sigma.
Over.
N squared. Squared.
So changes slightly here. Start with x bar again. Then it's plus minus what? This time it's z. Do I have it switched? Am I looking at this? Yeah. So they're switched. I'll just listen to it. So then what did I have? Z. I'll get there eventually. Okay. Z. So this one should be what on top?
S.
S. This one.
Or now.
I'm not gonna listen to you. Okay. This one is sigma. This one is squared in. We'll get on track together. Okay. Now this one is T. Now I'll think while I write. Which one goes with 2? S. Just so that we understand pieces of that equation, what does ME stand for? Margin of error. If you don't know what ME stands for, I would write underneath margin of error, but hopefully y'all know what ME stands for. So just going through which part of the equation actually is the margin of error. What over here is the margin of error for my first equation? Starting where?
Z.
So everything after the plus minus, and that applies for all three equations. Everything after the plus minus is your margin of error. This one is just T and S instead. This one is starting with Z and then going to the square root P hat 1 minus P hat over N. All right, so my margin or my confidence interval equation breaks down to part of it being margin of error. My margin of error equation breaks down into two parts. What's the first part? What is this in general called? Critical value. This is some form of standard something. Just so that we understand, I want to write standard error. So if I say we're going to do a whole row of standard error, you should have an issue for one of these. Which one? There are two of them that are fine. Which one of the two that standard error that it has a standard error? What is standard error? Standard error is similar to standard what? Standard deviation. Why is it called standard error as opposed to standard deviation? Because we are using a what?
Estimate.
We are using an estimate for a parameter. So of these three equations, which one does not use an estimate?
The middle one.
This is a parameter. So here, I'm not going to have a standard error there because that actually is my standard deviation of X bars. Here, I didn't know sigma, so I had to estimate it using S. So what section of this equation is standard error? So the only thing standard error means as opposed to standard deviation is we had to use a statistic in place of a parameter when we were doing the standard deviation section. So then this one is going to work as the whole square root part because we are estimating what as what? We're estimating P hat as P. Questions with standard error. I'm gonna just go to another slide so I don't have to write on the bottom. And then I'm just gonna keep going with what I have up here, maybe move those bars around. All right, so this is continuation at this point, the first one. Okay, so let's talk about method. What is my method for the first column? It is a one sample, what? And how does it end? For means. I kind of made this connection yesterday, but there are a couple things that I just kind of take for granted when I make the connections. And I don't know if I did it on a video or in a class. Why is it helpful to know what our method is? Where do we see it written like this, similar to this? Where? In the calculator when you go to test? It's not written out in words, but it's like 1 dash and then so forth. So this one, what changes here? Just the Z becomes what? T. And our third one obviously isn't for means anymore. What's the whole thing of this one?
One sample, interval for the tokens.
So I'm going through pieces of the 4-step. Is it really worth it to write out a bunch of stuff for state? What's the only thing that changes in state? For the most part? Your mu and p, and then whether you use the word mean or proportion. I think y'all are okay with not writing that down. So method is the first part of plan. What's our first condition of plan? Random. Is that one worth writing down? No, why? Same for all of them. What's our next condition? Normal. That one is worth writing down because it is not always the same. Now, technically here, these are the same. So I'm doing this to give myself more room. You can either like make this one box or write it here and then just doing, like write it here and then do an arrow this way showing that it's the same. So how many options do I have for checking normal when it's with means? How many options do I have for normal? 3. And these aren't necessarily in order that you have to check them this way, but what's one of the easy ones?
Problem states that.
And it stated specifically that what is? That what is normal? Population distribution. And sometimes they'll say it's approximately normal. What's my other easy one? Central limit theorem, what's my easy thing to write beside that to help me remember?
Tens
Greater than
equals.
or equal to 30. And then my last one would be, it's a histogram of what? Of values. Checking 2 things. What are the 2 things?
No extreme outliers.
And
Not overly skewed.
and then I might just do something all the way across the bottom that says so we can. So I'll wait and do that one once I've done this. When I'm checking for proportions, chapter 8 is different than chapter 7. And how is it, what's the one thing that's different with chapter 8 checking my normal for proportions? P is p hat because we don't have p. We always want to use p. If we can't, we have to use p hat. So n times p hat has to be what? And n times 1 minus p hat greater than or equal to 10. And then there are at least 10 ... You might write success, failure. And then so I just do something all the way across the bottom so we can. Instead of writing it twice. Okay, so our last condition is what? Independent. Any reason to write that one? No, it's all the same. And then our last section of before, then our next section would be do. Why am I not writing do right now? Because we just wrote what? Confidence interval and margin of error and standard error. So we've already done the do section. So there's only one other thing that we might deal with, which would be minimum sample size. Now this is a little funny with this first section. Why is it a little funny with, I guess technically this middle one? What can you not use when you're solving for a sample size? You can't use t because you need n to be able to solve for t. We're solving for n, so that won't work. But I'm just writing it under here as a mean. Like when we're dealing with means, if you want to do it just for the first one, not the second one, that's fine. All right, so you do not have to memorize this. You can just use algebra to get it, but let's go ahead and write it. This would be that our n is greater than or equal to what?
T squared times the standard deviation over the margin of error squared.
And again, you do not have to have that memorized. You can go through algebra to get there, and that is fine. But just writing it all together. And then for proportions, we're still doing lowercase n is greater than or equal to. What are we going to have on top? And so this is where it's different. Here, the squared encompasses the whole thing. Here, the squared only encompasses what's in the denominator.
Margin of error.
About what? And so which part is squared? The whole denominator. Any questions that were brought on by just going through this whole list? So it's nice to see what things are the same, what things are different, to kind of help you make sure you're looking for those things or paying attention to them. I will say when we put stuff together, one of the most often mistakes is probably people trying to use central limit theorem when it's a proportion, which you cannot do. One of the worst mistakes, like as far as like that one, obviously you should know that, but you definitely do not want to get z and t mixed up. Okay, and there's one other thing I want to go over. Again, I think this is probably me taking this for granted because people weren't asking questions initially, but I've had a lot of questions about this, and so I want to go over it. And I think it's going to help a lot. The up arrow, down arrow, margin of error, confidence level, confidence interval stuff that we had on the quiz review. I think y'all are getting way too caught up in trying to memorize which plus minus goes with increase decrease, as opposed to thinking about what the heck's going on. And if you actually sit down and think about what's going on, it makes life a whole lot easier. So let's just look at my basic example that I use a lot. Let's say I'm 50% sure that the weather is going to be a high today between 66 and 72. I am, and I'm just using exaggerations here, I am 90% sure that the temperature today, so if I'm going to do this, if I'm 90% sure, am I going to go lower than 66 or higher than 66? Farther away, lower. So let's say I'm going to say, I don't know, 50, 70, no, 80, what did I do, 16 more, 16, 88, trying to be consistent. That part you can follow with me, right? Like you can make up numbers to do that. So what is this as a vocab. Margin of error. So as my percent got bigger, what happened to my margin of error? It got bigger. So what happens to the width of my confidence interval? It got bigger. So that part should be really easy. What's our margin of error equation? Let's just say we go with a z for means. What is my margin of error equation for z for means? Times directly related and indirectly related. If I want to see how this changes, what things over there? I've got three things. I've got a z, a sigma, and a square root n. I have two that are going to have a direct relationship change with margin of error, and one of them is inversely relationship. Which two, the way they change is going to change my margin of error? And I'm asking this in a strange way because I'm trying not to give the answer first. So which one, as it gets bigger, is going to make my margin of error smaller?
N.
N. So mathematically, algebraically here, why is n inversely related to this? Where is n?
Bottom.
On the bottom. So do you see why that is indirectly inversely related? Things that are on top, as the things on top get bigger, this whole thing's going to get bigger. As these things on bottom get bigger, this gets smaller. So this whole thing should hopefully clear up a lot of those issues that you're trying to memorize, down arrows, up arrows, as one increases, the other one does what. Draw out a simple example like this and think through it. And then anything with margin of error, as these two do something, my margin of error is directly changed the same way. This one is indirectly. So if I say something like, as my n increases, okay, well, what we just talked about, we know that as my n increases, what's going to happen? So what does that mean with my confidence interval width? What does that mean with my confidence interval width? Because we just went through that same idea here. So just making this connection up here and this connection, you should really be able to think through all of those pieces of that up-down chart. Does that make sense? Now, if I change my n, what is not going to change? So did my margin of error change if I change n? Yes. Did my confidence interval width change? Yes. But what doesn't care what my n is? Standard deviation and z. So don't accidentally get those mixed up. That this is changing those. This is changing something over here. What questions do y'all have from there on this idea? I'm going to stop it a second.